Prove that angle P is equal to half.
But what does that mean? What does that mean?
Oh, it's that one that you showed us.
We're proving that an inscribed angle is half of the arc, is basically what we're doing here. So that theorem I read you, this is the proof of it. Okay? All right, so here we go. Draw OA. Why can we draw OA? Oh. Yeah, y'all just have to tell me. Sometimes I forget because if you look at that statement on 10, aren't they just looking up, and you already said in step 8, didn't you say that P and PAO were congruent, right? So if they're congruent, they're equal. So couldn't I just say, hey, couldn't you substitute in angle P for angle POA because you said that they were equal? So that would be substitution. Substitution and addition. I would put for 10, I would put substitution. And if you want to know where you're substituting, you're taking number 8 and you're putting it in, you're taking number 8 and you're putting that information into the statement on number 9. And that's how they're getting what they wrote. And then they just added angle P plus angle P is 2 times angle P. So they just added after that. When we did proofs in high school, this book doesn't, if y'all were kind of looking at the answer book when we first got started, but when we did it in high school, we always stated the steps that we were substituting from into like this, just so it'd be easy for somebody else to follow what we were thinking when we said it was true. But then we had to write the steps and the reasons. So we had to do everything. You didn't get this much information. Okay. So that was just, they substituted 8 into 9, then they added them together, and that's how they got the statement on number 10. So angle P is a half of AOB. Why is that true?
Theorem 63.
What now?
Theorem 63.
Okay, so all they did on step 11 was they took that 2 times angle P equal angle AOB. All they did was divide both sides by 2, and that's where they got angle P is a half AOB. So the only thing you really have to write there is just division. All they did was divide both sides by 2. You see it now if you didn't see it before? Now, why is the measure on number 12, if you look in your book, why is the measure of arc AB equal to the measure of angle AOB? Look at the second figure with all the red drawn into it in the book at the top of the page. Why is arc AB equal to angle AOB? What kind of angle is angle AOB?
It's theorem 63.
I want to... Isn't angle AOB a central angle, right?
Yes.
The central angle is equal to its intercepted arc. That's why those two are equal, because AOB is a central angle. Remember, with a central angle, the angle is equal to the arc, right? Angle P is equal to half measure AOB. Why is that true? Look.
Because you already told us this.
Well, I know, but we're proving it. Look at 11 and 12. What did they just do there? Didn't they just make a substitution?
Yes.
Because they said the arc and the angle were equal, and then up above they said that P is half of AOB.
Theorem 63.
Well, no, we're proving theorem 63. We got to quit saying theorem 63 because we're proving theorem 63. Huh?
They substitute?
Yeah.
Okay.
They use substitution there. So the second part here is about proving that if the sides of the angles are chords of the circle, that inscribed angle is still half of the intercepted arc. So they're just being very thorough and making sure there's not an exception to the rule. Because if I say it's a theorem, I'm saying it's always true. So we got to think about what's the funny little things that could happen. Is it true in those funny little cases? So let's look at this. It says draw PO intersecting the circle at C. Okay, so I can draw that in, right? Why can I draw that in? What would be the reason that it's okay to draw that?
Because is it
It's that itty bitty thinking again. I can draw it because between any 2 points, there's exactly one line that joins them, right? Okay. I'm just going to put there as a line. I'm just going to abbreviate it that way, but there's only one line through any 2 points. So I can draw that line, and it's the only line that would exist that would go through those 2 points. Now they say angle APB is equal to angle 1 plus angle 2. So first of all, we got to go look. Where did they put this angle 1 and this angle 2? Here's 1, and here's 2.
Isn't that complementary?
Let's see. Okay, that's just the betweenness theorem. So let me write it in a different color since I actually wrote the statement down. That's just the betweenness theorem or arc addition. It's a betweenness theorem for arcs, or you could just call it angle addition. Those two angles add up to the bigger angle. So that could probably just angle addition would be the best thing there. I keep looking at the arcs and angles and interchanging them in my head and with the words, so I'm sorry. Okay, so we can split it up into angle 1 plus angle 2. Have we said that angle 1 and angle 2 are equal yet at all, anywhere? No. Okay, so we're not saying they're equal, they're just saying they add up to that bigger angle. 16 says because angle 1 is equal to a half of arc AC, because why did they tell us? Why do you think they told us to draw OC in there now? Because look what they're saying. They're like, oh, wait a minute. They're using that theorem that we just proved, right? The part of the theorem we just proved. Didn't they just draw a diameter in there so they have two angles that have a diameter as the side, Misha? Didn't they just do that? Absolutely they did. Are y'all with me? Okay. When we put this line in there, what they did is they're going to take advantage of what they proved in case 1 and use it now. They're going to split this angle up, and now I can use that theorem that we just proved on step 13. We just said as long as one of the sides is a diameter, we knew that this was true, right? So now they're going to create that situation and use it to their benefit. So we can say angle 1 is a half of AC. We can also say angle 2 is a half of CB, right? The part that one of them cuts off this, and the other one cuts off this, right? Okay. So they're just taking advantage of that. You may have to look on your book now. Angle APB. Oh, wait a second. I'm on the wrong one. 17. No, are we on 16?
I don't think we did 16.
Oh. Well, we did part of it, and that was we did the part that used like step 13 above there where we said as long as the side was a diameter, then that was just that, the reason for that was just true is we could say case 1 of theorem 63, because we just got through proving case 1 of theorem 63. I was talking about how we had that diameter, right?
So 16 was theorem 63?
The case 1 of theorem 63, what we've already proved in 6 through 13. It says APB is a half of AC. And, here's what they're saying. There's another part to that. So this is part of the reason, but then look at the statement they make here. Angle APB is a half of AC plus a half of CB. since we know that this is like the case we proved already, we can say that if since APB is made up of AC plus angle 1 plus angle 2, and angle 1 is half of AC, and angle 2 is half of CB, then we can just kind of substitute all that in there. And so it's also equal to half of measure arc AC plus measure arc AB. They're just factoring out the half then. And that's true from substitution. They took number 15. Angle 1 plus angle 2 is APB. We knew that 1 was half of AC and 2 was half of CB. We know that's true because they both have sides that are diameters. And in step 13, we concluded that proof that said as long as the sides were diameters, an inscribed angle is half of its arc. And they're just substituting that in, taking number 15, taking what we know about inscribed angles with sides that are diameters, and then they're using that to substitute in the first part of 16 there. So really, the reasons are this case 1 and then substitution. That's really all that the reasons would have to be there. I've just written down some of the work so we can kind of look at what they did. 17 says the measure of AC plus the measure of CB is equal to the measure of AB. So look at those arcs, those pieces of the circle. Why is AC plus CB equal to AB? Don't those two pieces add up to the whole?
Yes.
Isn't that all that that's saying? So that's just arc addition. Arc addition. We're almost done. We're on the last one now.
We have 43 before, so.
Oh yeah, I didn't see that. If we don't get to it, we'll just cut it off. Well, we still got some time. Okay. Okay. 1/2. Stop this.